Okay, everybody gets to click the little button. Welcome, everybody. This is January, must be the 15th? No, let's start over again. Welcome, everybody. This is the Sarah Drake Lounge, and we're up to February 15th. Uh, Glad you all made it. We'll have a nice talk. Rich said he was having troubles with his computer, and so he pointed at me. I know how to push these many buttons anyway and get it recorded up on the cloud. Jay, do you have any update on the conferences coming up for us?
Well, hello, everyone. Just very brief overview, and we may have some committee members online, so I don't want to steal your thunder. If you have things to add, once I've gone over the dates and general outline, please feel free to step in with more detail. Our first upcoming event is going to be our Western Conference, which is March the 14th through the 16th, Socorro, New Mexico, at the site of the Very Large Array, the National Radio Astronomy Observatory, VLA. I understand tours of the VLA are set up. The conference itself will be held at a nearby conference center, I believe operated by the university, but it is more convenient to the motels in town as well as restaurants than if we tried to have the conference out in the center of the site itself. But sounds like an exciting program. The ezRA website has got a brief overview, and the ezRA online store has got reservation links for both online participation as well as in person. So if you haven't signed up yet, now is a good time to do that. I'm not sure who online, I'm not seeing the conference committee online, but once I'm finished here, Tad, if you could see if any of the conference committee members are here to talk about the program and more details about who the presenters will be. In June, we have a very exciting conference set up in West Virginia at the Green Bank Observatory. The observatory has been recently reintegrated into the National Radio Astronomy Observatory network. So there will be some administrative changes, but according to the information we have from GBO this week, our conference will not be affected by any of those changes. Conference dates are June the 7th through the 11th. That's a change from previous years. Saturday the 7th will be a hands-on workshop held in one of the workrooms for the Science Center. And here we hope to have those who are interested put together a scope in the box, set it up with a computer running ezRA, take the dish outside and start looking at H1. So we should be able to do that all in a single day, along with some good presentations by Don Latham and a couple of others on what is it we can do with those kinds of instruments, how can you tailor them to your home needs, and what research outcomes can you expect. That'll be on Saturday the 7th. Beginning on Sunday, Monday, and the first part of Tuesday will be our regular sessions that will be in the Jansky Laboratory. Beginning on Monday afternoon and Tuesday, we'll have a joint session with Radio Jove. The details, I think, are still being worked out on how we'll integrate the two programs, but Radio Jove has indicated that they will work with us on a joint conference This is about the first joint conference we've had, I think, in 5 or 6 years. So it ought to be very, very rewarding for people who've got an interest in Jovian studies. And then on Wednesday, we'll have tours of the observatory, including some of their laboratories, control rooms, and we hope the Green Bank telescope. Green Bank telescope access, of course, is based on their maintenance requirements. They're undergoing some pretty heavy maintenance right now. And if it's safe to have us do a tour of the facility, the staff there is planning on arranging that for us. That's what I have. The June conference is not yet listed at our website. I think Marcus Fisher is working on the final details of that. Should be up fairly soon. So there is not a link on the ezRA store for registration just yet, but I'm thinking right after the 1st of March, you should be able to expect that. So Ted, with your approval, if there are any committee members from either of those two conferences, would like to hear from you. I don't hear anybody. So over to you, Ted.
Yeah, I'll leave a gap, but hearing nothing. Let's go to our ezRA treasurer if we can. Tom, what news do you have for us?
Let me get unmuted here. I do have some comments about the registrations. One of the things that I have to ask people to do is if you are registering for multiple people, I need contact information for everybody who is registering, at least a name and an email address. And the best thing that you can do is to put that information in the additional comments section at the ezRA store. So there's a text box in there where you can enter that information, and it will really help me out and probably save you getting email from me asking for this information if you have not provided it. And that can slow your registration down. The other thing I need to say is that there are a steady stream of Western Conference registrations coming in. When I looked at my computer just before coming in here to fire up this computer and join the meeting, I saw that there are three registrations for the Western Conference for yet to be processed, and one that's going to require me to send some email to someone to ask questions. But I will do that. I don't know just exactly when in-person registrations are going to close, but I also know that that will be sometime so that they have time to do the mailing. So don't wait to the last minute because it might disappear from the ezRA store and you won't get it done. And if there's other questions, go ahead. I'll be here and I'm going to let up on the button that allows me to talk. So I'm about to silence myself. Well, I'm not hearing anything, Ted, so I guess I'll give it back to you.
Oh, here I am talking away and no one was hearing me. We worry about time zones here. Those folks in the east want to go to sleep. So we're going to start off to the east of the world with Dimitry over in Russia, if we can, and then work our way back. I'll pick on Wolfgang and Edward next. Dimitry, are you there?
Hello, everybody. I today about interesting measure. I still not observe it, but some info about this measure I can present in just a moment. This is pulsating measure. mm, mm, this galactic coordinates of this maser. Very interesting. It can be observed very well in northern hemisphere. It's well seen in methanol and water frequencies. Some hydroxyl lines also observed, but they're very weak. Uh, uh, this maser have well measured period of pulsations, 34 days. The next peak in methanol is expected about 12 March, and it have very interesting properties I will talk about. Possible nature of this maser is a binary systems, rotating binary system, which modulates seed photons. This not protons. Sorry, this is photons, seed photons, and or pumping radiations with very well defined period. Um, Periodicity of this method is not still fully explained, and all info I present here is based on most of info I present here is based on this work. This is a group from Poland. They are they're very experienced animators. Pulses of this maser in time very narrow peaks in methanol and peaks and water. Water peaks is higher. The vertical scale is integrated flux density, but width of lines is about 1 kilometer per second for methanol, and levels of peaks for methanol measure is about 100 Kelvin. For water measures is up to 1000 Kelvin, about 500, 600, 700 Kelvins for water measures. It is not very strong, but well observable, detectable by matter telescopes with rather long integrations. It can be detected, surely. Ibaraki, I met data for 6.7 gigahertz maser. Very recent, last data January 25. Period 34.4 days is well confirmed by this plot. You can see levels can be even higher than 100 Yansky. I for 12 March it may be even less 50 Yansky. It's hardly to detect by I'm intended to to observe to try to observe these measures in March. About lines, about spectrums of water and methanol. Main line in water is about 16 kilometer per second. Water 16 kilometer per second. For methanol is about 7.5 kilometer per second. Lights you can see lights for water measures is up to 1-2 kilometer per second. Can be estimated with of lines for water. For methanol is still 1 kilometer per second is interesting properties of this measures. Water lines came in opposite phase with methanol lines, and if methanol peaks is about March 12 for 22 gigahertz water measures, it can be expected about February 23, and this is rather strong. 500, 600 Yansky can be observable if closest date is not some fall, is not some systematic fall in both measures. It should be tried to observe this measure. And some physics of pumping of this measure for methanol. Infrared radiations that pump these measures observed simultaneously with this measure. Infrared peaks and methanol peaks do not always coincide, but when they are definitely correlated. Infrared peaks and methanol peaks for two bands in infrared. But when they coincide, you can see plots for infrared in polars and methanol in line, methanol in line. Radiation, they're well correlated, and it shows that methanol measures is well pumped by infrared radiation. This is second class of methanol measures. This is all for full info for now. If our measurement will try to observe it in 22 gigahertz, it's okay, thanks.
Thank you, Dimitri. Fascinating data. So many cycles, so many phases going on. That's interesting stuff. Inspiring. Any questions?
Okay.
Thanks, Dimitri.
Maybe just a comment, or thanks first of all, Dimitri. You say the 23rd of February is expected for the water measure, so looks like we're going to give it a try to see whether we can actually observe it.
Oh, that's exciting. Now you can start comparing.
Okay, it's very well.
Yeah. Well,
it's very well.
Now, Wolfgang, so if you're going to give it a try, thank you, Dimitri, very much. Wolfgang, you're next, so I'm going to just start. What dish are you going to use you have to get a feed in the right place.
Yeah, we have a 10-meter dish which we use for water maser observation. So that's not something that we have to set up separately or just for that purpose, because we are doing regular water maser observations since I don't know, since maybe 2 months or so, or 3 months. And we're still looking at what options we have in terms of water masers that we can observe. And that certainly we put on our list. It looks like if I need to read through the paper that Dimitry has just shown and to see what the expected flux densities would be, but I had a quick look and that looks like it might be doable. So it's just a matter of giving it a try. Essentially, that's going into things that we do and which I want to report. There's not really something new at this time. I mentioned our water maser observations already. That has turned into I would say, routine operation. So every couple of days when we have time, there are about 5 water masers that we visit so far. Another activity that we had in terms of masers, just a couple of days ago, there was a astronomer's telegram from the Torun telescope in Poland, where they reported that they had seen a flare of methanol masers at 6.7 gigahertz on ezRA. And we were hoping or considering that methanol maser at 12 gigahertz would flare as well. But we checked it, I think 2 days ago. We checked it again today, and there are no flares on 12 gigahertz. So that seems to be either this maser has, the flare has declined since it was reported a few days ago, so it was just a short flare, or the flares are independent or don't show in the same or in both frequency bands. So masers are an exciting subject, I would say, especially because they are variable, especially the water masers tend to be quite variable, exciting things to observe. So that's all I have to say for today. Thanks very much.
Thank you, Wolfgang. I'm impressed with the trees behind you. They look very green for this time of year. Very good.
Yeah, it's not not a live picture. Actually, we had a little bit of snow this morning at the site.
We had a bunch of snow, so it's not the picture behind my head either. Well done. Thank you for your news. Working on time zones here again. We're going to go to Edward if we can, and then maybe Henrik, and then Andy. Edward.
Hello, hello. Do you hear me?
We hear you fine. We see you good. What's new?
So yeah, essentially I've been doing some work on extragalactic hydrogen still. I don't have any maser work to report right now, so that will wait for another time. So yeah, I'm gonna share my presentation right now.
And do tell us where you're located for the record.
Yeah, so I am located in the Netherlands. So we are a very cloudy country, so not great for astronomy, but still it's okay for radio astronomy because you can look through the cloud. So yeah, I'm usually I'm working a lot on masers in recent years, water masers in particular. And from time to time, I also do still some work on the hydrogen line with a 3-meter dish that you can see here on this presentation slide. So yeah, this 3-meter dish, I built this thing over 7 years ago. It started out as a school project, got a little bit out of hand, as you can see. So it's essentially, it is composed of 4 segments that are usually just stored in a shed. So they are dry and safe from the weather, from wind and rain and everything. And yeah, whenever we have a couple of days or weeks of stable, good weather and dry conditions, I just set it up and do a bunch of observations. So today I just want to tell something about the extragalactic hydrogen observations that's ongoing right now. So this kind of started a couple of years ago, actually, when I did some transits of Messier 33, of Messier 31, the Andromeda Galaxy, which was inspired by the work of Jean-Jacques Mentux, who did some excellent work on detecting Messier 31 and Messier 33, and even making like spectral surveys of those galaxies. And more recently, Jason Burnfield also did a bunch of extragalactic hydrogen observations last year, and besides Messier 31 and Messier 33, which are sort of like the most nearby galaxies and therefore the easiest to detect, he also detected a bunch of other galaxies, or at least a couple of them, he claimed. And this kind of interested me because I wouldn't have expected these other galaxies to be detectable, because if you look at the flux densities of these galaxies. So Messier 31 is at 120 Jansky peak flux density, and then Messier 33 is about half as strong, and we know these can be detected with some difficulty. And then the other galaxies, yeah, it starts to drop off real fast after that. So for example, Messier 101 is one of the galaxies that Jason may have detected, and it's at only 16 Jansky, so it's much weaker than Messier 31 and Messier 33. So it's a bit surprising that we can detect this at all. So yeah, in recent months I have been able to detect Messier 31 and Messier 33. I'm still working on IC 342 and Messier 101. I'll get back to that later. So yeah, what the setup basically consists of my 3-meter dish with a 1420 megahertz VE4MA type feed. It has a G8 FEK LNA. There's a bandpass filter. There's an extra amplifier to overcome the cable losses, and then I use an AirSpy Mini SDR and the IF average plugin to record spectra. So the methods that I am using and that Jason also used for his observations is called the drift scan method. So I have explained this in earlier RTOP presentations. So I won't go into too much detail, but the essentially what you do is that you just you point the dish towards the south at the elevation where the target source, in this case the galaxy, transits through the south. And so every day your galaxy that you're observing passes through the beam of the dish, and the beam is in the half power beam width of my dish is about 5 degrees, so I get about 20 minutes or more of useful integration time every day, depending on the declination of the source, of course. So it's further, if it's further up north, the transit's going to take longer, and if it's close to the celestial equator, it's a bit shorter, of course. So what I also do is that I collect spectra before and after the transit of the source, and this is to essentially do the background correction, because of course, the bandpass shape of the SDR, the bandpass response is not flat, as everyone who's doing hydrogen line observations knows probably. And you have to subtract this bandpass response to reveal the weak hydrogen line, especially the very weak extragalactic hydrogen line signals. And for the extragalactic sources, I'm just using like a series of spectra recorded before and after the transit of the target, because this way you kind of compensate for like any sort of gain or temperature drifting that might happen like in between these times. So Jason and I both found that this method works really well to reveal these very, very faint signals. So yeah, you can see that as well. So here I've made a plot, for example, with the spectra from before and after the transit of the target and of the target, in this case, Messier 31. And you can clearly see like the SDR bandpass response, this very curved response. You can see the hydrogen line from like a local area in our own galaxy. And the extragalactic signal is just so weak that you cannot even see it here in this spectrum. But after you subtract the spectra from before and after the transit, then suddenly you start to reveal like these very, very faint extragalactic hydrogen signals. So unfortunately for my Messier 33 observations, it wasn't so easy this time around, because I was having a lot of problems with interference. So here you can see an example of a spectrum that really didn't turn out nice. You can see a lot of spikes and interference, and yeah, the faint extragalactic hydrogen signal is just completely buried in these RFI spikes. But I did note at some point that the strength of this interference varies a lot with where the dish is actually pointing. So at some point I found out that by pointing the dish a little bit more to the southeast instead of just straight south, the RFI is already a lot less. So presumably the interference is like coming, I don't know, probably somewhere from the north or the northwest, and is being picked up. It's being picked up in a side lobe of the antenna. And so by carefully positioning the dish at a different azimuth, you can kind of like try to minimize the RFI getting in. Unfortunately, my pointing is not super accurate because I'm just using like a compass for like the azimuth pointing, so it's not very it's not the most accurate way. Yeah, I was initially having some troubles like correctly positioning the dish. So I was having much less interference, but initially I was not really seeing any signal of Messier 31 in this course. So I was just trying to point on Messier 31. And I didn't really have a way to use like the sun for calibrating the pointing, which I would normally do because the sun is a very strong source and very easy to detect. Because, well, at this moment, the sun is just too low and it's just like between buildings and between trees. So I cannot pick it up right now. So yeah, but after just experimenting with positioning a bit, I finally got a decent result on Messier 31 after a couple of days of trying essentially. So yeah, this was a test run on Messier 31, 10th of February. So you can very clearly see like the spectral profile of this galaxy. So you can see this sort of like double horn profile with a sort of redshifted peak at minus 100 kilometers per second and a very strongly blue shifted peak at minus 530 something kilometers per second, and some weaker emission in between. So this is very typical of this galaxy. But yeah, I already knew I could detect Messier 31 because I've done it a couple times before. So then I went back to Messier 33, and yeah, this time around with the pointing solved, I still had some issues with interference. It was not completely gone, and what I noticed was, yeah, these observations also just require some luck. So essentially, sometimes, most of the times, I have a pretty good stability of my system. And the results turn out quite nice, but other times, as you can see here on the right, this is also a drift scan from the 13th of February, and you can see that there's these like variations in the background essentially. So there's presumably like some fluctuations in the gain of the somewhere in the receiver chain. So either at one of the LNAs or at the SDR. I don't know what's causing this, but if that happens, well, you just have a bad result, as you can see here. So here on the left again, there's the result from February 12th, which was when I had a good gain stability. So you can actually start seeing the profile of the Messier 33 spectrum because the background is really flat after subtracting the off-target spectra from before and after the transit. And for the 13th of February, that just didn't work very well. And you can see there's still a lot of residual curvature because there's these like gain fluctuations going on during the transit, and that's kind of like ruining your result. Yeah, luckily that for the past 4 days, I've been collecting transits of Messier 33. That has only happened once. So these are the results from the other 3 days, and you can actually see they turned out quite nice. And yeah, after averaging all these spectra from February 12th, 14th, and 15th, there was still some residual curvature left, which could be removed by fitting a second order curve through the background, essentially through the parts of the spectrum outside the hydrogen line emission from the local area in our galaxy and the hydrogen line emission from Messier 33, and then subtracting that curve. And then to improve then to improve the signal to noise ratio a little bit more, we can reduce the spectral resolution, of course not too far, because otherwise you just wash out the spectral signature of Messier 33, but I reduced it to 46.9 kilohertz, which is kind of the sweet spot between like having enough resolution to resolve the details in the galaxy spectrum, but not so much resolution that you just see a lot of noise. So actually, this is quite a bit better than what I had about a month ago. So one other thing that I have done, and this is something I've been discussing with over on the forum as well with Jason, is that you can actually simulate these transits with the lab survey tool for comparison with your own data. So probably those of you who are working on hydrogen line are aware of this this data set, the lab survey that can be accessed via this website actually, which is really convenient. So you can just plug in the coordinates that you want a spectral profile from. You can plug in the beam width of your antenna, and in my case, it's 5 degrees for my 3-meter dish, and you get the spectrum. So I just downloaded the spectral profiles for the position of Messier 33 and also for the positions 30 minutes before and after the transit of Messier 33. So here you can see those profiles, and then I subtracted the off-target spectra from the Messier 33 spectrum, and you get our simulated transit spectrum. And then I compared that to my my own result, and you can see that there's a really nice fit. So this confirms that we have indeed succeeded in detecting Messier 33. So as I said, I'm also working on detecting some other galaxies. So I have been collecting transits of Messier 101. So far, I don't have any convincing results on that one. It's very weak, but I just continue collecting spectra and or collecting drift scans, and maybe by averaging enough of them, I can maybe extract a very faint signal. And then IC342, so I have still have some problems with the RFI because IC342 is very far north, and whenever I'm pointing my dish to the north, the RFI gets a lot stronger. So it's that one's just quite difficult to observe for me at the moment. So yeah, to be continued. So this is all I had to present. Are there any questions?
Thank you, Edward. That's exciting stuff, and you're even getting confirmation from big dishes that you're in the right territory. Well done. We look forward
Very
to
well
updates.
done. I see how nearby the solar panels are located.
So on the first slide, yes, yeah, those, yeah, I know.
As a source of RFI, you're worried about, right?
Yeah, the thing is actually that so the RFI does occur at daytime, but it also occurs in the evening when it's dark here. So then you don't really expect much RFI from solar panels. So it's also coming from some other source.
Are you using the power from them? Is it out of the inverter?
No. Those are from the neighbors actually.
Very good. Thank you, Edward. Good update. Keep it coming. Next on the list, I have Henrik from your ham call. It looks like you're in Denmark. Tell us where you are and what you're up to. And is this your first joining us?
Yeah, you're absolutely correct. This is my first joining of this meeting here, and thank you very much for the invitation also. And you are correct. I am calling in from Denmark. So let me just make a very, very short presentation of myself here. This is me. This is the station, and this is the home place. And let me see if I'm actually able to switch to another screen also. This here is the station. I don't know if you can see that. There you
Looks
are.
good to us.
Yeah, okay. This is the setup I have right now. I have a 2.5 meter dish controlled as an azimuth elevation, controlled by a Siemens PLC, and the receiver itself is with a I'll call it a standard setup for us, low noise amplifier and filters and SDR units. All that connected up to a PC. Where all the yellow boxes is actually something that I'm still developing on, and the blue boxes is up running perfectly as I want it to run. I'm working on this 2.5 meter dish for now, and when everything works as I want there, then I am planning to put up my 5 meter dish, which is just stored on next to it. But I'll make sure that I've found all the, what should I call it, all the errors and all the problems with it before I scale up to the 5 meter dish. What I have done until now is I have made a, let me see if I can actually scroll in some of these pictures. Yeah, I have tried to make up a map of the hydrogen sky, and the green stuff here is what I have done already now. The yellow one is actually also finished just here the other day. So I have a complete map, or at least I have a complete data set with 2.5 degrees of deviation between the declination for 24 hours scan for each one of them. The red part here is not possible to see from my location. Next step here will be to put all these data files into a database and then try to find out how can I make a good, nice presentation of all that stuff here. This is basically what I have as an introduction about myself. What I am is that I am educated electronic engineer back in '86 with microwave as a specialty, and been into both optical and radio astronomy for some years now. So I'm happy to be part of this, and I'm looking forward to a lot of extra sessions here.
Excellent. We see all kinds of fancy stuff going on here. This is exciting. Plus, lots of data already collected. We're eager to see more results from you as it goes on. I hope you know all about our email reflector, the forum.
Yeah, I know that. But I need to find something to write on there before I actually. I'm reading the stuff that is coming in, but to participate myself, I need to have something serious to participate with also.
Well, we're excited. Someone's going to read stuff before they talk. That's marvelous. Excellent.
I'm trying
Thank you
to.
for your presentation.
Welcome.
Next, I have Andy, Dr. Andy, and then Alex. Dr. Andy Thornett is a medical doctor, but now we didn't know he was so much of a poet. Andy, what is the source of this poetry you posted?
Oh, I don't know. I just quite enjoy writing poetry.
Oh, so you wrote it. This wasn't GPT this time.
No.
Oh, okay. Well, thank you for the
So,
posting. I thought it was kind of fun.
yeah. I mean, even when I use ChatGPT, I tend not just to get them just to write it. I do a lot of direction, so it just use it to help find some words, really. But anyway, so would you like me to perhaps talk about what I'm up to?
Yeah, we want to know what you are and tell us all for the record where you are.
All right. So I'm in the middle of the United Kingdom, just above Birmingham, which is that massive cohabitation that's right there. So RFI is what we live with all the time. And for Henrik's sake, I'm the person who never reads what I write or even thinks about too much what I write before I either write it or say it in this forum. So I need you and Rich to tell me if I say the wrong thing. So it doesn't stop me from putting stuff on the mailing list. That's one thing for sure. Anyway, so I thought today what I would do is just give a bit of an update on what's been happening with the Solar Cooker radio telescope, because several people have been asking me over the last month or two where I've got with it. Seems to be quite some interest in that as a project. So just to remind people who don't know what this is about, if you give me a second, I shall just find a picture and show you what we're talking about here. If you live in the States, these are really easy to get hold of, and they're not really easy to get hold of in the UK, but excuse me, let me jump off a bit off. But they are, I was lucky. Somebody must have bought one some time ago, and there was a house clearance sale. So let me just find this now. Solar Cooker parabolic. So you actually get this thing in America called sunshine, which we don't tend to get very much of here. And because you get sunshine, they sell these things for you, which I will show you. Share screen. Right. So can you see that those eBay listings there?
We see the listings.
Yeah, which is 1,800 watts parabolic solar cooker. So I'm actually very grateful to, I can't remember who it was that posted this on the mailing list originally. If that person's here, perhaps they can put their hand up and say hi. But I'm very grateful to whoever that was for coming up with the idea. As we know, large parabolic dishes are extremely expensive, or it's relatively expensive anyway, and 1.5 meters is pretty decent size for most of us, and they're selling these things quite cheaply. They say about 82 pounds. In America, I think it's about $50 or $60 with a bit of postage. And see here, unfortunately, they require delivery from the US, or you can get it on AliExpress. Same thing, about £70. So that's what's a bit negative from this side of the pond. But as I was lucky, somebody had a house clearance and I was able to get hold of one. So that's what I put together to try and get it to work. I have had quite a bit of issue getting it to work. And I think it's probably because my antenna, which I'm using as a feed, is probably in the wrong place. That's what I learned at the last meeting. And I haven't yet had a chance to sort that bit out. But nevertheless, I do have some data using ezRA Astronomy. So I'll show you that to you now. Well, that's going. Forget that one for a moment. Come back to that in a second. Right. So firstly, where's it gone? Where's it gone? Where's it gone? Here it is. I'll just show you that. So, I'm currently undergoing my third mapping exercise of the Milky Way. The first one was done right at the beginning. I say both of these first two mapping exercises were done with an ex-military dipole array, which has got 4x4 dipole of the right frequency in it, what is called military band 3 here in the UK. And it's 86 by 86 centimeters in size and seems to perform about the same as a 1 meter dish. So the first mapping exercise I did was 6 elevation points with drift scans. So therefore it sort of obviously did the whole azimuth 360 degrees, but then at 6 different points. And this is the results of the second one that was about sort of 20 odd elevation points. I'm limited in how far I can go because of my latitude, which is 52.5 degrees north. It limits me down where I can go, but nevertheless, I was able to get quite a decent map and find this incredibly exciting exercise. So I want you just to bear that map in mind. And oh, by the way, this was what I thought were the names of the arms on there, but I'm really happy for anybody to come in and tell me I've got it wrong. If they can correct it for me, Wolfgang or Alex or anybody else who could say to me, hang on, you've got the wrong names, because I'd rather get the names right rather than do the wrong ones. Anyway, moving on from that. So I've now got, sorry, Alex pointed something out, I think it was, at the last meeting. Forgive me, Alex, if I'm blaming you for something you didn't say. But it was to do with the length of the integration times per data point. I think you actually might have sent me an email about it. That's right, Alex, I think it was. So I'm, as everyone knows, a massive fan of Ted's ezRA Astronomy, which is, I think, an absolutely stunning piece of software. And he keeps improving it all the time. And I'm pleased to be his main beta tester. So I try out everything he does as soon as possible. And he's going to speak to me at the end of this meeting. And I'm hoping he's got some new ideas as well about what he's going to do that I can try out, because it'll be very exciting. But one of the things about ezRA Astronomy is its default integration length is 15 seconds. So there was quite a bit of a debate about whether that level of resolution really had any meaning with a 1 meter sized dish. I think the conclusion was really you could go up to about 4 minutes without seeing any loss of real resolution. So what I've done on this third mapping exercise is I've now I did with ezRA Astronomy, it's not quite so easy to know exactly what is 4 minutes, because you can't set 4 minutes. You have to set the number of samples, and clearly it depends on your computer speed as to how many samples will constitute 4 minutes. So I did a lot of experiments over a few hours and eventually worked out something that was give or take 4.5 minutes, something like that. So the third exercise is on that level of integration. So I'm going to show you some of that data now. Right. I've got it up here. Yeah. So just to check, you can see it. Does it say initial data analysis from new Milky Way mapping exercise? Ted, does it say that?
It looks great. We see the whole screen.
Yeah. Excellent, brilliant. Just check it's come up. I'm always frightened that it's not appearing your end. Anyway, so we start with the ptarmigan array. So as you can see there, just to show you on this particular plot, shows you the 4 different elevations and shows the data collected, so you just know what this is from. This give or take covers the range that I've got, even though it's only 4 elevation points. I would just say I can't really go that much further than that. I can go further north, where it gets beyond the Milky Way, right up to 0, without, so up to 90 degrees without any problems at all, but doesn't really give me much extra information. So here we are. So this is just showing you some of these, some of this data that's coming out. It always interests me that we measure the arms, but in fact in 3D you can see that the data actually goes almost into a corona that goes over the top, which I find quite interesting. And here you can see the another arm. So the first arm, the bigger arm there, which I think is the Sagittarius arm, I believe, is the one that you've got the green and the yellow and the little bit of red in the middle, which is obviously much brighter. But you have this, shall we say, less bright second arm on the outside starting to form now. It's obviously limited data being used on this. And again, just a couple of different, couple of different perspectives to show that. Okay, now moving now onto the solar cooker. So the first thing that we can see is it got the same number of data points, but this data's neither coming exactly the same each time, nor does it have the correct peaks where it ought to have quite as, or at least to the same height as it ought to have. So at the last meeting, it was suggested that this might be due to the fact that I've got the antenna not quite in the right focal point. So I had to go through a process of trying to correct that. But again, after I finished in a few seconds, Wolfgang, Alex, Ted, anybody, please make any suggestions you want as to what else might be causing that problem. Because you'd have thought with a 1.5 meter dish that I'd have had a significantly better set of readings than on the ptarmigan. Anyway, looking at the data. So here's the data coming through there again. You can see that the Sagittarius arm is starting to show up quite strongly, as you would expect, moving aside. But the obvious thing that's missing here is that second arm, which I think is the outer arm or the normal arm, I think it might be, is missing on this data. I think that just shows that I'm not picking up that fainter arm on the outside. So just some different perspectives. Now I do have something else to show. So Alex was the one that came up with Rinnen 3D, of which I think we got a lot to thank him for that, because it's an absolutely marvelous method for actually demonstrating your data. So this is the solar cooker radio telescope data here, which I've put into Rinnen 3D. I was doing it while everybody else was speaking, and then I accidentally closed it down, so I was rapidly opening it back up again. I managed to do it in time. But what I want to do is, although we know that outer arm isn't showing up, I just want to show you this when you move it around, which quite interests me. If we actually move the graph around so that we take that Sagittarius arm out the way, we can see actually that we seem to have another smaller arm on the inside and a spur on that Sagittarius arm coming out, which I found quite interesting. Anyway, that's me done.
Thank you, Andy. All sorts of things to study there, and we'll be chatting after the meeting. Anyone's welcome as we yak upon.
But
any questions there for Andy?
Or any comments on why I might not be getting the right data sets that I should be getting from this particular radio telescope?
Have you checked your pointing? Because that was a problem for me as well.
Well, I mean, the Milky Way covers
he's doing a drift scan, so it's just a matter of getting data all across the whole sky. So pointing, I don't think, is the first problem. It just seems to be sensitivity. Now you got to tune your antenna, Andy. I don't know. Sure, moving the antenna around is a great start.
Do you mean too much sensitivity or not enough or some frequency?
I'm speaking of that he can't see the faint objects, so he needs more sensitivity out of his antenna, or at least the system. Andy?
Yeah, I mean, it's certainly not an issue with coax cable because I've changed it to KMR 400. So I've got heavy duty stuff there.
It's the tedious process of taking data, looking at it on like SDR Sharp, that you get a quick real-time plot, and repositioning parts, measuring them, making sure that the can is actually physically centered within about a centimeter of the center, and moving that antenna in and out in maybe perhaps 2 centimeter steps over a range of 5 or 6 centimeters, and plotting it out, and then finding the gap, the optimal position, and then trying 1 centimeter steps. It's trial and error. It takes hours to tweak this stuff, and that's what needs to be done.
Yeah. I mean, Rich came up with the idea last time that it would be worth putting some little bit of mirror segments on the dish when it was a sunny day, and then I could use that to try and help find out where the focus point was, at least the center of the dish anyway.
I've gotten those little square mirrors from a hobby store in the past.
Yeah, I bought
the
a
other
few
thought
of them.
is, if I run long coaxes out to the LNA, and so I have to worry about the voltage that's actually powering the LNA after such a long cable. But I don't think your cables are very long, so I don't think that's our big problem here.
No, about 2 or 3 meters of KMR 400. That's all.
As opposed to my 50 or 100.
And there's a box. Yeah, there's a box out in the garden with a little mini PC in it that acts to collect the data for this.
All right. Other comments for Andy then?
Alex is
hi, this is AC. I'm out here in San Diego. I have a question. Has anyone tried doing the antenna adjustments with some type of a signal generator where you're actually say across the yard or something with a small level signal at 1420, and then trying to align the antenna using something like that?
Amplitude is way too high.
Oh, even if you have a very, very low power signal, it's still too much.
The levels you're talking about are a third to a fifth of the radiation levels from the earth and trees and around you. So it's nothing. Pointing it at the grass, you get 3 to 5 times more radiation than the H-line signals you're trying to detect.
Well, what I'm referring to is to line up the antenna. You're referring to trying to find the right focal point for the antenna and so forth, and so maybe using a small signal to try to make that alignment, just measuring the amount of power
you can do that, but then you need mobility of the dish or the source, and that solar antenna, cooker antenna is not that maneuverable, and then you're trying to position a feed source 20 feet, 30 feet up in the air. So it winds up, some of these things don't work on some of these small systems.
What you would need to do, well, in order to not to have too much signal, you can go directly to the dish without an LNA, but you need to make sure if you have a transmitting antenna that you are in the far field. So you have to calculate what is the far field for your antenna. The bigger your antenna is, of course, the further away you need to go. I'm not sure what it would mean for a 2-meter dish, but certainly something like 50 meters or so to be sure to be in the far field. Then I think finding the focal point would be an option by doing that, provided that you can direct your antenna towards your transmitting antenna.
Well, 50 meters is probably about 4 gardens away, plus hedges.
Yeah,
and
I haven't done the calculation. It's just from my gut feeling. How far do you have to have your transmitting antenna so that you're sure when you do the focal point adjustment that you have a source that's in the far field? I know that for our 25-meter dish, it's 20 kilometers to be away to be in the far field.
Well,
not very practical.
That's a nice problem to have. Okay.
Rather than using an actual transmitting antenna for the signal source, I was thinking of just putting a ballast on the signal source, so it would actually just be the minimal amount of radiation and not actually directed at any so kind of a isotropic sort of a radiation source that would be would be attenuated by not actually having an antenna at the signal source.
It doesn't change whether it's maybe a isotropic radiator or so on. It has to, in order to align the dish and the focal point, it has to be, the source has to be in the far field, no matter what the source essentially is. And I think it could be doable for a small dish. Well, that's 50 meters or maybe 10 meters. One has to do the calculation, but that would be an option.
Professionally, I have made these adjustment of feed horn location or placement many times before, but that is exactly as you were saying, Wolfgang, that is in the far field. And for a 2.5 meter dish at the H1 frequency, we are talking about 58 meter or so, meaning that that you have to be quite far away. It just came into my mind that maybe in a calm weather you could use a drone and have the signal generator on the drone. That could actually work out, but it could be interesting to hear the results at least.
So my 50 meter gut guess was almost about right.
Quite good. It was quite good.
So I think I need to go back to what Alex has said and get SDR Sharp working on it, point at the sky and then fiddle. But also what Alex said is quite irrelevant. He said maybe only 1.5 meters, and my wooden mount may only be another 1.5 meters off the ground. But to get up to the feed, you're probably needing a step ladder. It's
That's the problem. And the bigger the dish, the worse it gets. As I think it was Henrik was saying, once you get the bugs worked out on the small system, so you know how to implement them on a large system. That's why I was so successful, I think, with my small 1 meter, is that it was 1 meter. And doing these tests, what I was just speaking of, I would wait till one of the bright areas of hydrogen was overhead, and I could make a change in 30 seconds. I could run out there, shift the feed, jump back and look at the reading and write down the numbers and go again. And being able to have that level of flexibility is significant. And you develop a routine, you understand what's going on. And if you're having to climb up a ladder and almost fall in a dish to try to develop the feed, it becomes more challenging.
yes. Well,
Okay,
thank you
thanks
very
a
much,
lot.
everybody.
I appreciate the comments. It was just an idea that I had, and was trying to just put it out there. Thanks a lot. Appreciate it.
Oh, can I make one last comment about the solar cooker radio telescope? It's made of very light metal, as you might expect at this price, and it does rust very easily. So one of the things I did right at the beginning, which I think was a brilliant idea, was to buy some aluminium and zinc spray paint, which happened to be being sold cheap in a local store, hardware store. But that was has helped keep the rust at bay, but not completely. So I think it's really important to keep going back and keep spraying it on a regular basis. Otherwise, it'll be an X solar cooker parabolic dish very quickly.
Andrew, or clean it well so that it is nice clean, and then coat it with some boat coating, white boat coating. I've done that on my parabolic, and that works perfectly.
White boat coating.
Yeah, just coating for the boat. Basically,
paint,
for
you
the
mean?
fiberglass. Yeah, fiberglass paint. Yeah.
Okay. White
That works
fiberglass paint.
fine for me.
Okay, thank you.
Excellent. This is the place for ideas. All suggestions are welcome. Very good. Next I have up is Alec. Well, first off, let me ask. I think we've got everyone from far away Eastern time zones. Now we're down to the Americas. Is that right? Anybody to the East? Very good. I'm going to call on Alex first, and then Bob, and then Jack, if I may. Alex, what's new?
Good afternoon. Not a whole lot. I'd like to say hi to Henrik. We've exchanged a few emails and ideas over the past few weeks. I don't have a whole lot of input. I'll share just this. H-line 3D project, that if anyone has any questions on it, I'll be happy to ask. Otherwise, you've seen most of this before, but the project entails fairly easy construction of a lightweight Yagi antenna, and using some processing software that's available, something that was custom designed between Jameson Adcock, and I added a few features to the conversion program that produces output files that are compatible with linear and 2D and 3D software. It's a nice package. I don't really have anything else. I've been working with a local university and a high school. I think I'm getting some students involved in building that Yagi. And so it's in the early stages, but at least one of the schools had gotten the SDR sharp and IF average operating, but it's a long way to go. It's not trivial for young people. It's extremely complex. In fact, that's why it has kept me occupied over the past 5 years. I have a good background in this stuff, and it's of sufficient complexity that's kept me interested. And that's all.
Thank you, Alex. Appreciate all your design going on there. Do give us a link to H-line software in the comments for those watching by YouTube.
It's just do any search, DuckDuckGo, Google on H-line 3D, HLINE 3D, 3 Delta, and you'll go to the GitHub site. I'll post it, but it's easily searchable.
Even better when it's easy. Bob, what's the news when you're
sorry, Ted. Sorry, forgive me, Ted. Look,
Andy
before Bob
first.
comes on, can I just show something and ask people whether this is what's being suggested?
Andy first, if I may.
Wait a minute. So forgive me for going back. But is that what's being suggested that I should paint the dish with?
Yeah, that could be. I'll prefer the white one, but that's just because I love the white color. But yeah, that could easily be the one.
Well, this one comes in all sorts of colors. But anyway, my apologies, Bob,
Exactly.
for taking over. Sorry, I'll get rid of that. When I can find out how to do it. Wait. Screen change.
But make sure that you clean your parabolic before you try to code anything on it.
Okay, thank you.
Okay, yeah, I think the reason he's suggesting the white one is to keep the temperature down, right? To keep it cooler, which might make a small difference between gray and white. It's not a lot of difference, but maybe white would be better.
And
But
Wolfgang had a comment too.
Right.
Yeah, I have a comment on painting the dishes. One of the things that you need to take care of is the infrared reflectivity. It has to have diffuse reflection on infrared, because otherwise you're focusing infrared radiation into your focal point, and you might burn things. So you be careful a bit with the kind of paint that you use. Ideally, it has to be certified for dishes, but that's probably an expensive thing to go. But be careful about burning your cables.
Yeah, so probably a satin finish or buff it after you paint it with some steel wool or something to make it more non-reflective, I guess.
That might be a possibility, yeah.
Mhm.
So I just want to mention it.
Yeah, I don't really have anything to add today. I've just enjoyed all the fine presentations people are making, and need to get busy myself and do more to present. But I'm in North Texas too, by the way, just for the record. So back to you, Ted.
Thank you, Bob. Jack, what do you got news for us?
Oh, well, not really a whole lot of news. I did build actually two of Alex's disc Yagis, one using the wooden dowel as a backbone and the plastic spacers, and the other one using a stainless steel threaded rod and aluminum spacers. And I found with the VNA, the ladder seemed to give me a deeper null. And with a great deal of assistance from Alex, I was able to get a good set of scans last week, one evening and morning, of the H1 line, or the drift scan of the Milky Way going overhead, which was way cool. And it's my intent going forward is just to continue to tune things, and you guys are so much more knowledgeable about this than I am, but to tune my system and to learn more. And then maybe once I really understand this stuff, go on to a small dish. So that's all I have.
It's a slow process, and that's the cool thing is take it step by step, and it's not attaining the goal. It's the little surprises and rewards along the path are what you'll remember, and that's what's good is take it slow and learn the incrementally learn how to adjust things.
Oh, thanks, Alex. And I guess I don't know if the software, the Java software, is proprietary. But I'm wondering if the source code is available. Just like if I could read that, I'd understand it better.
Well, let me ask Jameson. We'll think about that. So
Okay,
I
no
have
problem.
his
No
code
pressure.
and I modified some of his code. Let's see. We'll think about that. Okay, but it's it's free. It's not proprietary. Anyhow, I'm thinking about making some mods to that if enough people start to use it.
Well, there's no pressure. I don't want to step on anyone's toes, but thanks for your help, Alex.
Thank you, Jack.
Glad
And
to do
Alex.
it.
I have AC, Osmar, and Charles. AC, what's news with you?
Well, not much. I'm still trying to get started with setting up equipment and so forth. And weather out here in Southern California has not been too conducive for doing outside work. First with between the fire warnings and now deluge of rains. So it's been pretty much just indoor activity for a while. I had a quick question for Andrew. Number one, on the solar cooker. Is the solar cooker not made out of aluminum? Is the corrosion on the actual reflector itself, or is that just on the supporting structures or whatever?
Well, just on the edge so far, whether the rest of it, the rest of it is aluminium or what, I don't know, because I did actually spray it quite comprehensively right at the beginning, and there's a mylar coating on the front anyway, which I sprayed over because I mean after that made my leg start to burn, and then managed to burn a great big hole through a cardboard box. I thought I need to do something about it.
I'm
I see.
pretty
So
sure that dish is also just a stamped steel structure.
I see. Okay. And then I had a further question regarding the comment that I made earlier regarding trying to line up the feed on an antenna. What about reflecting the signal off of a distant object? So if you were just to aim at a building or something that you're trying to reflect the signal off, would that be considered a far field signal if you were to try to attempt to do that?
If you get too far, if you do all of these interesting things, then you have to certify they work. It's easier just to use the source that you're trying to detect rather than, if you knew with what your antenna, how it performed, then you could try bouncing signals off of a nearby building and see if it worked. But you can't base these novel ideas without actually qualifying them some way.
I see. Well, my intent was just basically to try to find an approximate focal point for the antenna, not necessarily fine tuning it, but just so if you could get it into the general sort of placement, and then possibly fine tuning it with an actual H1 signal. So that was kind of my idea of trying to attempt that. But anyway, that's all I have to say. And I'm listening in and just trying to absorb a lot of the information that everybody's presenting. So fantastic
But AC,
reports. Yeah.
but AC also, if you want to put a reflector, a microwave reflector somewhere to try to reduce the distance, that wouldn't work because the reflector would then have to be in the far field as well, because that will be your new point of signal, so to say.
I see. So you're saying the reflecting surface would have to be also considered to be, so that would have to be in the far field of the actual signal generator itself?
No, not of the signal generator, but from the antenna that you want to measure on, that you want to adjust, because the reflector would actually be your new signal source.
Oh, I see. Okay, but yeah, it would be a lot easier to find some reflecting surface that would be further away than to actually physically place your signal generator at the far field distance. So that's what I was kind of thinking in terms of.
Yeah.
Okay. Well, thank you very much. I appreciate the comments. That helps a lot. Thanks a lot.
Very good. I had Osmar on my list. Have you dropped off, Osmar? I'm looking for you.
I'm here.
Oh,
Can you
I'm
hear?
sorry. Yeah, okay. Your picture has arrived. What's new with you? And where are you?
Virginia Beach, Virginia. Okay. Let me share something here. Let's see if it's going to. There it is. You see that?
We see a black screen with a yellow trace.
Okay, so
that looks like it came from hardware, right?
Yeah, the peak is
I'm saying
near,
from Spectra Cyber, correct?
yeah, it's near the Milky Way when it was seeing that peak, and it's got a hip down here. I was wondering if that's a second cloud or if the radiation from the first cloud is passing through another cloud.
We're getting energy at different frequencies with this scanning frequency detector. And yeah, if there's energy out there at those frequencies, you're detecting it. So it could indeed be coming from a hydrogen that's moving differently than the hydrogen at that peak.
So basically you're saying that's a second cloud that's kind of partially behind the first cloud?
They're all on the same, line of sight where your antenna is pointing, but there are some along that line of sight that are moving towards us and some that are moving away from us. Yeah, so there are a couple of clouds on that spike.
Okay, ignore the interference.
If you want to check your spectrum from your hydrogen line spectrum, if you know the position where where your antenna is pointing, and you have an idea of the beam width of the antenna, then you can use the lab survey tool to simulate what the spectral profile for that position would look like. I'll send a link in the chat.
Which survey tool is that?
It's a lab survey. I'll send a link in the chat.
Okay, thank you.
I just posted it.
Oh, you. Thanks. Okay.
All right. Let me see. I'm trying to figure out how to unshare now.
I have powers.
Okay, go ahead. Unshare me.
Usually at the top of the screen.
Stop sharing. There it is. Okay, thank you. That was it.
Very good. I'm lost in buttons here. Charles, I had next up. Charles, what's new with you? And tell us all where you are.
Okay, I'm in near Winston-Salem, North Carolina, so almost on the same latitude as Preston, but a little further west, about probably 150 miles further west. And I've got a 3.7 meter dish. Let's see if I can share that. I don't. Yeah, here we go. So does that show up? You're seeing my dish?
Yes.
Okay. All right. So yeah, this time of year, of course, we've got lots of rain and stuff, so I can't go up to very high angles because it will collect a pretty good puddle of water in that. So, and we've got 5 inches of snow forecast for Wednesday, so it'll be interesting to see how that affects things. But right now, I guess in the picture there, I'm probably pointed at about 15 degrees, maybe 10. So I can go almost down to 8 or 9 degrees elevation. And let's see, like today, I think I'm at about 30, 35 degrees elevation. And I think that's negative 19 declination, something like that. Anyway, so some of the
I like all the
issues.
luggage you have out there. It looks like you're about to move out. What's in all the boxes?
The boxes are the mount for the antenna. So let's see. Are you seeing my pointer?
We see your pointer right next to your shadow.
Okay. The first hexagon here is the elevation axis is right in this part, and that clips onto another hexagon that is from here to here that is the azimuth. And so there's a motor in here and some gearing, which is very difficult to get to.
Oh, I'm sorry. On the picture, we see a mouse, and I thought that was yours live. So I guess we don't see your mouse.
You don't see my mouse,
But
okay?
we see your picture down on the bottom, your shadow on the bottom box, and those are hexagons, not. Oh, now we see the mouse move. Carry on.
Okay, all right. So right above where my shadow is where it splits and does an azimuth motion. And then the very bottom hexagon is just part of the mount that has the legs on it. And then these back hexagons here with the cement blocks on top are actually hooked into all the other hexagons to provide the weight in the back that keeps it from moving around or tipping over in the wind or something. So this is all sitting on the ground, no concrete, just its own feet and the weight of those cement blocks to make sure everything stays nice and solid. But anyway, it's it has various problems. It's like 20 years old now, so I need to actually take things apart. But it is a nice dish because I can unclip the portions of the dish and take it apart. Can take it all the way back down to where the dish pedals are actually storable in these hexagons, and then move them out of the way. So I could actually relocate the dish in about a day or work on things. But anyway, it's still a fairly big project. It takes 2 people to lift the elevation axis off of the azimuth axis box once the dish is gone. So let's see, what else have I got that I could show? It's probably, let me stop sharing. Anyway, that's on 1420 right now doing drift scans, but it would work for methanol, which I'm tempted to try to do. But it would be better if I could get some of the motion control working. I can move the dish from my office up on the 2nd floor, so that's handy, and the receiver is up here in the house. So only the LNA, the Sawbird H1 LNA is the only thing that's outside, and then about 100 feet of RG214, which is about the same size as LMR 400 type coax. So works pretty well. Let's let somebody else have some time to talk. Go ahead, Ted.
Thank you, Charles, for the update. Next, I have JP.
Can I just ask a question to Charles,
Wolfgang
please?
first. Wolfgang first.
Yeah, just a question to Charles. I noted you have a fairly long feed horn, and that actually is interesting to me because today we had some discussion, also some measurements about the benefits and the disadvantages of having a long feed horn. So I'm wondering, what was your motivation to make your feed horn relatively long?
Okay, it's a transmit receive feed horn with a septum polarizer. So it's a square feed. I think it's, I forget how long, maybe 15 or 16 inches. So it does have good mode control as far as making sure that it doesn't pick up cell phones and stuff like that as much. I don't know how much rejection it has, but more length is better for a little more cell phone rejection. And then it does have the scalar ring around the outer portion. It's a big cake pan or some kind of pan to be the ring to help form the side lobes a little better so that it doesn't spill over from the dish. Although I do still see some issues with there's something in the house that makes 1420 interference. And so at higher angles, I start picking up that spur and it shows up in like 5 or 10 dB out of the noise at higher angles. So I do have enough spillover or side lobes that it sees the RFI from the house.
Okay, thanks very much.
That answer? Okay.
Yeah.
Wolfgang, for a university, you had a dish that had a very long feed horn, and you were hoping to cut out some RFI. What are some of the disadvantages of a long feed horn then, for a cantenna anyway?
Yeah, it looks like, well, first of all, it's very successful in suppressing anything at the lower cutoff frequency. And just today we did a comparison measurement about that. But anyway, the disadvantage seems to be that on the upper side on the frequency, the drop off at the upper cutoff frequency is more rapid than we would like to have. The idea is that we would like to use the feed horn both at the 1400 but also at 1600 for the OH masers. And it looks like that for a long feed horn, we get quite some attenuation for the 1600 compared to 1400. But still, we're working on that. We're doing measurements as far as we can and try to understand that a bit better. But again, the main motivation is broadband, being rather broadband with a feed horn. And that may be counterproductive using a very long feed horn.
Okay, so for my 1420 studies, I could make it long, and that would work fine. I will explore. Next is JP, and then Helen, and then Don. I think that's it. JP. I'm sorry, I was putting down initials. And he has left us. All right, Helen, are you still there?
So I'm just trying to learn all that I can and looking forward to the conference next month. And we're about an hour and a half north of Phoenix in Arizona.
Good luck on your adventure then. We want to hear results when you get them.
Okay, thank you.
Don, it's your turn. Tell us what's new.
Oh, a couple of things. Wolfgang, what's happening at the upper end of the frequency is it's mode shifting. The energy's moving out of the TE11 and moving into the other modes, and that happens worse and worse as you go higher and higher. I'm sure, yeah, this is what's happening to you. So, and I'm not sure how you counteract that. The other thing, let's see,
I did do a deep dive on the length of the probe in a cantenna. I have something like 7 books on feed horns of one kind or another. All of them are full of mathematics and very low on practical anything. And because that's where the information comes from people that are having to publish new stuff. So they keep publishing new stuff, but nobody ever builds a damn horn. So the pickup length is indeed supposed to be 1 free space wavelength approximately. And what it is essentially is a quarter wave stub that matches the impedance of the stub to a 50 ohm cable or 50 ohm input amplifier or whatever you have. And that can be tuned to have a maximum power transfer. And it's somewhere very close to a quarter wave stub on an infinite plane. So, but the distance from the rear of the cantenna to the stub is 1/4 waveguide wavelength. And of course, Wolfgang, I think you will appreciate that, of course, because for 1620, you have to go closer to the closed end and like around a quarter turn or something from the 1420 pickup stub, or else make the 1420 pickup stub real fat so that it'll pick up the 1600 as well. It just lowers the Q if you make it fat. If you make it a little thinner, it has a little bit of a higher Q and you can still tune it. So I took the deep dive on this because every one of the books that I looked at starts out at the back of the horn with a piece of waveguide and never tells you how you excite it properly. And this to me means that it's a craft, it's an art, and it's not published almost anywhere except perhaps in a few places like Paul Wade's very excellent cantenna in things. The other thing, so the length, there is an upper length kind of limit where you can get away with that, I think, but it is indeed shorter because the longer the thing gets, the more modes you excite at the upper end of it. So it's always a trade-off, as we know. The other thing that called to mind is with this aiming business and getting the focal point in the right place, don't forget that the minute you come off of the vertical, you're going to have mechanical strength problems too, because you can get quite a bit of displacement on the support structure for your feed. Edward, for example, has sort of a flexible parabola, and the feed support is very close, if I remember it right, and it's like a central pole kind of feed, so that when you tip it to the side, the feed is going to sag a little bit, and you could be out a centimeter or so, or even more. So it might happen that your feed point's actually moving as you rotate your dish in elevation, and this can happen with that lightweight solar thing too. If the position of the supports for the feed should be so that at least one support is coming down from the top on your elevation feed so that it provides a fixed length into the support for the cantenna or whatever feed you have built, because I'm sure it can move. I think Alex is probably very familiar with this phenomenon. And by the way, Alex, you did show the effect of the cantenna as a filter recently, and something you put on the list somewhere. Was a couple of weeks ago, was it, or a little bit like that?
That was a picture from 2.5 years ago. That was
Okay.
that was the development of the 1.2 meter dish for the University of Central Florida. In that I did a site survey in January and everything looked good. I built up that RF design antenna and took it out there in August. And all I got was total saturation because in the meantime, someone had built a giant cell phone antenna behind a bunch of trees. And I had to bring out a small Yagi to even find the source. Then I could see the cell phone antenna. And then I think it was Wolfgang or some of you guys said, try the cantenna because of its high pass characteristics. And that was the result of, because initially I used a loop feed like I use on mine. And that plot was from about 2.5 years ago when I evaluated the cantenna and its performance, and it worked.
Yeah, that was a very, very nice single picture that showed you exactly what the point was. And I really liked it. I appreciate it very much. So I guess that's, all the silliness that I have for today. Look at your mechanical structure. Make sure that you have something that supports the feed as you rotate it in elevation, whether it's a solid bar or at least a cable or something from the top. And don't forget that the parabola itself is going to distort mechanically. And especially if you're starting to work at 6 gigahertz or, God help us, 22 gigahertz, you can get enough mechanical distortion in something like that solar cooker that you can throw your focal point completely off just by tipping the thing in elevation, especially at 22 gigahertz. So that's about it, Ted. Sorry.
Thanks for all the good news there. Gee, Bob?
If I could make a comment or ask Wolfgang, have you thought about, your feed is kind of like a waveguide, I guess. And so you can look at the waveguide equations and adjust the X and Y dimensions, if it's square or rectangular, or the diameter, to optimize it to cover both of those frequencies that you want to work. And then potentially insert 2 probes, one for each of the frequencies that you want to operate at, to get optimum coupling for each of the frequencies. It's just
we're looking at all these things right now. The background is we do have our 25 meter dish. It has a chaparral feed that's working fine at also at OH Mesa frequencies. And essentially what we want to do, we are planning to build a replacement receiver for that, which also means maybe a new feed horn. The motivation for that is that the present receiver box is fairly heavy and also too big to fit into, let's say, the opening in the dish. So it's very complicated if we want to do something on the receiver. So our basic motivation is we want to make the receiver smaller, so it's much easier to dismantle and bring it back in the prime focus than with the present receiver. And at that time, we're also looking at the different options for our feed horn, like what are the optimum dimensions for us, both in the diameter and the feed horn length and so on. We are doing as far as we can do it, some measurements on that. And of course, we know all the good advice and theoretical calculations. And we just try to really find the optimum because or before we actually do the final receiver design. So we're working with different sizes of feed horns and so on at the moment.
I have a question. Has anyone come up with a design where the antenna length could be incorporated into some kind of a telescoping sections where you could adjust the length for different conditions, and then perhaps being able to tune it for like the multiple frequencies that Wolfgang's referring to using?
Well, it can probably be done on a smaller dish. Our problem is that the prime focus is way up high. It's a 25-meter dish. It's the focal point is 7.5 meters above the apex of the dish. So this is difficult to come by. And doing this all by remote control and so on gets while theoretically it could be done, in practice we have some limitations as far as our mechanical capabilities is concerned to actually build things. So most of the time we are looking at using standard components, standard size tubes for the feed horn, etc. So probably we have to go and live with a somehow compromise fixed feed horn design where we can change things on the fly. And that's essentially what we're trying to do at the moment.
You know what, Wolfgang? I wonder if, just as a thought, supposing you had a longer waveguide wavelength for the 1420, and you put the 1600 at 3/4 of a waveguide wavelength for 1600, so that the effective point that you pick off would be closer to the opening. So the effective length of the waveguide for the first pickoff would be closer to the opening than it would be if it were a quarter wave from the rear. Am I making any sense? Does that sound?
The thing that we don't know is what is the let's call it influence of one of the pickups on the other.
Well, if they're right, if they're 90 degrees around, it should be okay, right?
Yeah, but we are using 90 degrees anyway because we're picking up both polarizations.
Oh, you're polarized. Okay.
Yeah.
So you have to have two. You have to have two pickoffs. Yeah.
We have two pickups.
90
degrees separate. And the other thing is a more practical limitation is LNAs. We would have to have LNAs on both pickups.
Yep.
And LNAs, we do have excellent LNAs, but we don't have many of those.
Right. Sure. Of course. Yeah, that just popped into my head. Sorry, but it gets rid of the mode switching so much. But yeah. Okay, sorry.
Everyone's
just
had
so many trade-offs.
So many trade-offs. Everyone's had a chance to talk. I think, what new subject should we talk about? More than what you said before? What else is new? Maybe we're done. I don't know. Sorry, guys. Well, thank you very much, folks. Another great meeting with so many topics to consider and study and be inspired by. Thank you very much. The next one coming up should be on Friday, right? Here in the USA anyway, on Saturday in Australia. So the Australian Drake is coming up. Look for notices on the forum. Thank you all. Bye-bye.
Goodbye.
Let's see. So I got to turn off recording is the plan.